So I'll go ahead and get started. It's Bob Brooks this month. We're going to be doing basically a training session on silica awareness for most people that are joining. For you that are SSHOs and may need to deliver this program, we'll get a little more detailed towards the end of what we've got available for you to do. A little bit of background with me with silica. There was one period of my life when I worked with a company called the Structural Group, and we did building envelope work, we did garage work, was very involved with silica control in those areas to the point where we had garages that we had under negative air and had filters and stuff like that because of the amount of dust we would put up in the air. Most times people were wearing full face respirators. That's not the situation I think we're ever going to find ourselves in at ECC. Most recently, we put together, I was in Lahaina for 5 months, so we got to a point where we were going to put our own recycling in for both concrete and metals. So that involved a concrete crusher. We're going to see a little bit of that as we go through this today. So we very quickly had to put together a silica awareness training once we got to the point where we were going to get operational. So I put that together. Conducted a training for both our people, Army Corps of Engineers. We also had folks from a company called Alpha and Tetra Tech that were involved. So that's kind of background for me. So I do have a lot of awareness and training and ability in this. Key training points today, what is silica and the standard, and we'll link in a little bit about what the Corps wants us to do with that, mainly putting information in plans, APPs, AHAs, stuff like that. Health hazards, obviously, with silica. Control measures we can utilize for exposures. Competent person, that's pretty typical, but we'll kind of talk specific to silica. And it's the exposure control plan requirements. We'll touch on those a little bit. If any needs help with one of those, I think Sally sent the one out that we did for our work in Lahaina. I'll touch on medical monitoring. I don't think we'll ever have to get into it, but the medical monitoring is very similar to what you would see in the HAZWOPER program. I think they almost cut and pasted it word for word, and the only thing they added into it was monitoring people for tuberculosis, which is specific. And then I'm going to talk a little bit about Mount Rushmore. That's a very interesting case study in silica and what it did to folks. So moving on, what is silica and silica's OSHA standard? This is going to take a little time to load up, so I'm gonna start it. It takes about a minute, I think, before we get moving. It disappeared on me. Okay, where are you? Okay, I knew that might happen. I will send the link to everybody for that particular video. But what I will tell you, oh no, it's actually running now. Okay, so we'll go through it. But this was actually published in 1938, and the OSHA standards, OSHA didn't even start until 1971. So it's very interesting that we go back to 1938 and see how bad the silica issue was back then. So, can everybody hear it?
No, we don't hear the sound. We just hear you.
Okay. Well, I can't help that. This is Sally inputted this. So let me do this. I'll send everybody the link after. You can watch it. It runs about 13 minutes, but it's kind of an eye opener to how long this has been going on and how long people have been exposed to silica. So silica, I mean, the most common term you'll hear is crystalline silica. You know, we find it in sand, stone, granite, rock, man-made materials. We deal a lot with concrete, bricks, blocks, mortar. But the most common form that we'll see is quartz. It's obvious a hazard in the workplace when it gets to a reciprocal silica dust, when it gets airborne. So that's the very big concern. The particle size itself is about 100 times smaller than a grain of sand. So it's very small. And typically we're going to find ourselves potentially getting people exposed. You know, we do a lot of concrete cutting. We do a lot of grinding on concrete. In Lahaina, we're crushing concrete. We've got a crushing system going on. drilling materials and such like that. So there are a lot of means now that you can get it, and obviously sandblasting's in there too. Uh, Three typical forms: you'll hear quartz, you'll hear crystal baylite, and tritomite. Uh, again, chipping, cutting, grinding, crushing operations, all are going to get people potentially in um, that predicament with exposures. Also in the glass manufacturing foundries, other things. Um, Reason for the rule, when they first published it in 1971, it was based on old formulations, and it was in milligrams per cubic meter, and the formula was kind of, complicated. So you go another 20 years, and then it becomes listed on the carcinogen list. So that's been updated. We're now in micrograms per cubic meter, which we will get to in a little bit here. Uh, you know, Most of the things you'll hear is silica exposures related to silicosis, which we'll talk about in a little more detail, lung cancer, COPD, and even kidney disease. Uh, when you look at what OSHA published in the beginning, they figure about 600 more deaths per year. Majority of them are devoted to silicosis, but lung cancer can be affected by it. End-stage kidney disease, and they estimate that there's at least 900 new cases per year. If you look at the right side, that's kind of what an X-ray looks like when somebody's got silicosis. Basically, those red areas have turned into something like glass inside the lungs, so they're no longer operational at all at that point. Silicosis is not reversible; it's irreversible. It's often disabling. And progression will occur despite removal from further exposures. We know that from historical deals. You'll hear the words chronic, accelerated, and acute defined. Accelerated and acute silicosis are much less common. They were a lot more common back in the 30s and before that. But after that, controls started putting in place, but we haven't got past the point where people are getting, chronic silicosis still, and it still affects people. You know, any case of silicosis obviously is a breakdown in prevention, but if you've got acute or accelerated, that means that it's a very marked breakdown. It means like you've got dust up in your face constantly for a marked period of time. The other thing is if you have latent TB that hasn't been activated yet, silicosis can accelerate activating that. It's one of the reasons why they test for TB if you go in and get tested for silicosis. Chronic silicosis is usually after 10 years of exposure, but accelerated can be within 5 to 10. And acute is really still very rare these days, but it still can happen. COPD, there's various reasons why people get COPD, but again, silica can contribute to emphysema, so those kind of things can happen. And then you get into kidney diseases with the renal and the immune system. That can happen. Sclerosis, lupus, I can't even pronounce the next one. Rheumatoid arthritis is listed in there. So those kind of things are affecting people with silicosis too. TB I've already talked about, but people with latent TB are 33 to 30 times more likely to develop active pulmonary TB infections. This is often the case with autoimmune systems. I know I take Humira for psoriasis, and I get tested for TB every year. It's one of the requirements I have to go through. It hasn't affected me yet, but it's a possibility. Lung cancer, you got the 2012 in the international community, and then 2014 in the U.S. where it got listed as a known human carcinogen. Other industries where we'll find it, things we work in construction, we work in concrete products. There's some paintings and coatings, abrasive blasting, marine work, general industry. So there's a lot of industries where people can be affected by silica. Industries and operational exposures, if you look at what's on the slide here, Overwhelmingly construction workers are affected by silica, and then followed by GI and marine time. Obviously our business, has it multiple times higher than just about any other industries. Control measures that we use, I mean, typically there's two. Um, we would like to eliminate it, but typically you won't see elimination in what you got to do. There is substitution in areas like sandblasting. They can use other blast material that doesn't have silica in it, and that's happened a lot. Typically, we're using engineering controls. We're either going to use water or we're going to use a HEPA-back type system attached to things. And then we get down to PPE. We get to points where, we've got admin controls, which is mainly keeping the areas controlled so other people that have no business being in there are not in there. For example, in Lahaina, uh, our crushing operation is very close proximity to our scales where we weigh both the metal that's coming in and the concrete. So those employees, are an area of concern. They've all had silica awareness training. Um, we do have folks that are in the area that are wearing respirators when they're operating equipment because they're right on top of it. But we haven't, I mean, we've been testing too there. So between the water that we're suppressing with it, which is our main control, and we'll get to that in a second. Um, but I know probably people have seen grinding with stone and seeing what happens. It's just right up in somebody's face. But if you put water on it, it virtually eliminates the dust. Another example, a lot of grinding takes place on concrete floors and stuff once we pour to bring the surfaces down to even. So that's part of it. But if you look at the next side over here on the right side now, you attach a heap of vacuum to it and you can really control that dust if it keeps moving. Jackhammers, I mean, sometimes we're using jackhammers. Most of the newer jackhammers now have basically a misting device that hits right down on the bottom of the jackhammer and can do a lot of control. When I worked with structural, we were starting to build those types of machines because the new standard had come out and everybody was scampering to comply with it. This next photo is a photo of our crusher. This is about the end of the first week of crushing operations. So you can see the pile to the left. It's very significantly reduced at this point, but it grows every day. We probably bring 40 or 50 loads of concrete in with everything from regular dumps to extended dumps to the end loaders, end dumps kind of things. But if we go a little closer on the top there, we've got our first engineering control. Okay, we've got a water hose that hits it right when it comes off the top, so it eliminates a majority of the dust. We use water trucks on the pile too, and we also have a sand blaster. I don't think Nick's on, so I don't know if we've got it there yet. Do you know, Kim, if these ever got there?
I do not know.
Okay. But we also it wasn't just the concrete pile. When we started, all the debris, the metal debris that came in still had a lot of ash on it. So we also had to do the same kind of wetting methods. It wasn't silica related dust that we were concerned about, but it was just respirable dust in general. So we had to implement that there too. The PEL is 50 microgram per cubic meters on an 8-hour average. The action level where we get concerned is where we get to 25. I don't think we've got any operations where we can't put controls in where we get anywhere close to this 25. So you won't see us doing medical monitoring, anything like that. But you may get into something in your career, like I did, where you just can't control it if you got 25 jackhammers in a garage. So it gets a little complicated. If we go over 25, obviously we got to do some assessments about that. Respiratory protection, same compliance. We got the OSHA standards. Obviously, if we're installing controls, if we're doing work practices, we've got respirators that we got to use. What OSHA does have in the state is what they call Table 1. And basically what it is a table, and it's got, I think, 18 different subsections in the table that if you put these control measures in, like water or HEPA vacuums, you don't have to wear respirators, or it's got a couple more things we're going to see in a minute here. Um, things we can't do for housekeeping, dry sweeping or brushing is really a no-no. Use of compressed air is also a no-no. So we need to get to things like on the right-hand side here. Basically, again, it's a vacuum process. It could be a large heap of vac. It could be a heap of vac that we've got connected to a drill. Okay, because a lot of the newer drills that are coming out, what they actually have is they have a hole down the center. And in that hole down the center, as you go in and you drill, it sucks that dust back through that hole and contains it. There's some real neat stuff out there. Table one, if we implement table one, we don't have to worry about it. That's typically what we do. So we don't fall into things like having to do extensive air monitoring or put people in level C. We comply with the PEL, we're fine. This is the table, the 18 sections of the table. So do we use stationary masonry saws sometimes? Yep. Handheld power saws? Yep. Walk behind saws. So there's a lot of different examples here. And the biggest one we have right now, obviously, is we're doing a crushing operation in Lahaina. I don't know. Did we do that in California too, Kim?
Crushing operations?
Yeah.
Yeah, I
Did
think
we
we've
did
done.
did we do any recycling like we're doing in Lahaina?
Yeah, Travis is doing that.
Okay.
I don't remember if China Lake did anything like that or not.
No,
Okay.
we didn't.
So remember number 60. Okay, basically each one section of the table looks like this. You go in, this one, handheld power tools, saws, as long as we operate and maintain in accordance with manufacturer's instructions and we do water delivery system that continuously feeds the blade, we basically don't have to worry about respiratory protection. And that's without doing any monitoring, okay? Role of the competent person, obviously we have to designate a competent person. It's somebody that has, abilities, knows about silica, can put a silica control plan together, has the ability to make corrective actions. The same thing with a competent person. So typically, that's one that ECC will have to identify, and typically we're going to identify that on the AHA, or we can do it in writing. Frequent inspection of job sites also required. This is kind of a quick look of what you would have got initially. This is kind of the beginning of what we put together for Lahaina's operation. I put the plan together. We had other people sign off on it, but what we got to have in it, what tasks are we doing that can have exposure to folks with crystalline silica? What engineering controls are we working on? What are the responsibilities of people? What housekeeping we're going to use? And another one that's written into it is how do we restrict access? We're going to put concrete barriers up, or we're going to put cones up, or we're going to put fence up. We need to identify that in the plan. And obviously, we got to restrict access, and those processes have to be placed into it. And this is for people that are going to work adjacent to it. And limiting access is the biggest thing.
Hey,
It says we
Bob,
don't have to. Yeah.
Kevin O'Brien has a question.
Okay.
Yeah, hi Bob. Just to maybe you're going to cover it, but just kind of curious. Is there a wind when you're like I know you got the water, you're spraying water, but do you have wind controls like thresholds once the wind gets up
There's
to a certain?
nothing specific in the standard, but we start looking at it at like 20 to 25 miles an hour and we looked at that in Lahaina, and we started looking at shutting down about 20 miles an hour. If that
Okay,
was
thank you.
consistent for like 15 minutes.
Okay, thanks.
And that was and a lot of that was mainly because of the perception of what happened. There the place was so listed as everything was toxic to begin with, so they scared everybody. So you got to be very conscious of that when you implement this kind of stuff. But 20 to 25 is in that range. And that's if what you're doing, if you've got some good blasters on the water and everything like that, if you're seeing the dust come off at 20 to 25, it's time to start doing something different. And mainly it's probably shutting down and just keep water. Answer your question?
Yeah, you did that. That's good. Thanks.
A little bit more EM3 to 5. I touched on this already. Typically we'll put an exposure control plan as an attachment in the APP, or we'll submit it as a submittal, obviously, to add to the APP. There's a crystalline silicon evaluation that's in the section that you got to look at 6N, but as long as we're compliant with the OSHA standards, it's not something we got to worry about. Engineering and work plan controls in the AHA, or the plan. It's kind of either or. And obviously identifying a competent person for Silica on the AHA. So that's right there. So that gives our 385 side of the house. Medical requirements, I'm just going to touch on it briefly, but typically if you're going to have somebody exposed over those 30 days to 25 micrograms per cubic meter, it's very similar to what's in the HAZWOPA regulation, okay? It's got 7 sections. Basically what the diseases are. Components of the medical surveillance program for employees is in it as section 2. Roles and responsibility of the health professionals are in there. It also provides in section 4 discussion of considerations, including confidentiality, basically HIPAA requirements. It adds some resources that the doctors can go to, and it provides some sample forms, just like the HAZWOPA standard does. But again, we don't expect we're ever going to be in this. So we just wanted to touch on it and know people. Last thing I'm going to touch on here is Mount Rushmore. I think it was 1927 to 1941 is when they built it. So they built it over a period of 14 years. I think it was one of the contributors to, and that was the Secretary of Labor at the time, who did that. I won't call it a video at the time. It was a movie in 1938. And again, I'll send that out to everybody so you can look at it. Or I'd probably just send the presentation out to everybody. And you should be able to click on it from there. I'll get with Sally and make sure we got that covered before. But, the end product was here. But when they built it, they were using dynamite to blast, so that generated a lot of dust. And a lot of these folks were going to be on the face in these, basically, hanging in the swings with jackhammers all day long, and they got significant exposures, for a period of, some of them, 14 years. There was 400 people that worked on the project over those years. Little couple mirror photos, you get close. But if you look at this group right here, there was not one fatality during this project over 14 years. But 250 of these folks died from complications from Silica earlier in life than they should have when it was over. So that's kind of the extreme case. So with that, kind of short and sweet. I was hoping to get another 13 minutes out of that video, but that didn't happen. So now I'll open it up. Anybody got any other questions?
Yeah, Bob.
Greg.
Yeah.
Hey, Bob. Are they doing anything different for the sketch or the Crazy Horse monument that they're building right now?
I don't know. I'd have to look into that. I guarantee you they are now. I'll bet they're wetting it down.
Yeah, right.
I'll bet their jackhammers they're using, have got a mist on them. They'll probably have to control distances when they do dynamite. But I'll look into it. That's a good question.
The other thing is sort of a lessons learned. A lot of times you're out there and you got a contractor sawing concrete, and they always have water on it, which is good, right?
Mm-hmm.
Mainly to protect their blade. But then what happens? They have poor housekeeping, and that pile of slurry dries, and then gets airborne again with the wind and whatnot. So housekeeping is really important. I just wanted to bring that up.
Absolutely, and that's something we gotta keep on top of. I mean, you walk in one day and the vacuum's working. You walk in the next day, it's not working, but they're still thinking they're using it.
Right,
and you got a dust cloud that's clouded the whole area.
Right, and the vacuum has to be certain rated for the size of the blade. There's some specifics in that standard. You know, if you have a
That's
big,
why
yeah,
one of the recommendations is always go to the manufacturer's, instruction manual for the piece of equipment. It's
right.
going to tell you.
I remember over there in Camp Lejeune, one of the buildings we were working at, they're doing a lot of concrete cutting. And lo and behold, the contractor's gone, and here's all the slurry just sitting there. And of course, it dries, and then the wind blows through the building and kicks it up. So, just housekeeping is really
Well,
important
that's
with
something I can add
silica.
into this. That's a good point. So I'll find some place to add it. Because this, again, for you that may need to give silica awareness, we've got this presentation. We've got the 10-question quiz. You have the ability to tap into me, or we'll identify some other folks in the organization that can help you put the exposure control plan together. And we've got a format for it. And typically, this kind of conversation will take anywhere from 30 to 45 minutes based on questions, because I think I did it probably 7 or 8 times for folks because of the number of shifts we had in Lahaina. I was doing it out of the trailer, in the scale trailer, actually, with about 4 or 5 people at a time. Any other questions?
I don't see any others.
Okay, so let's talk about some of the training that's coming up then, kind of administratively. Nick has now taken my place in Lahaina, so I have taken his place doing the SSHO training alignment. Next month, Nick's actually going to be doing underground and above ground utilities. Tim Woods is going to do PFOS, and I'm not sure what's the acronym for, Kim. I don't know if I've heard it before.
It's the perfluoroalkyl, whatever, the PFAS chemicals from firefighting foam and
Oh,
other
okay.
plastics.
Got it.
Yeah.
Great. We've got injury case management listed for August. I've got something I put together with that. Some of the other ones we're looking at, hearing conservation and construction. We're putting together, a specific procedure that's not 1910 related. It's 1926 related. We're hoping to have that out by the end of the year. Kim, there's a big effort with HR, and Kim and I and other folks that have put into, career progression. That may not happen by the end of this year, but I'm sure we'll have it next year. So anybody got any other topics they want to see or they'd be willing to present, give me a shout. I can help you work on it, get it ready, and we can go from there.